This lecture is a continued discussion of generative probabilistic models for text clustering. In this lecture, we're going to continue talking about the text clustering, particularly the generative probabilistic models. So this is a slide that you have seen earlier, where we have written down the likelihood function for a document with two distributions in a two-component mixture model for document clustering. Now, in this lecture, we're going to generalize this to include the K clusters. Now, if you look at the formula and think about the question, how to generalize it, you will realize that all we need is to add more terms like what you have seen here. Right? So you can just add more thetas and the probabilities of thetas and the probabilities of generating D from those thetas. So this is precisely what we are going to use. And this is the general presentation of the mixture model for document clustering. Right? So as in all cases, we follow these steps in using a generative model. First, think about our data. Right? So in this case, our data is a collection of documents, n documents, denoted by D sub I. And then we talk about a model. Think about a model. In this case, we design a mixture of K unigram language models. It's a little bit different from the topic model. But we have similar parameters. We have a set of theta i's to denote the word distributions corresponding to the K unigram language models. We have P of each theta I as the probability of selecting each of the K distributions to generate the document. Now note that although our goal is to find the clusters, and we actually have used a more general notion of a probability of each cluster. And this, as you see later, would allow us to assign a document to the cluster that has the highest probability of being able to generate the document. So as a result, we can also recover some other interesting properties, as you will see later. So the model basically would make the following assumption about the generation of a document. We first choose a theta I according to probability of theta I, and then generate all the words in the document using this distribution. Note that it's important that we use this distribution to generate all the words in the document. This is very different from topic model. So the likelihood function would be like what you are seeing here. Right. So you can take a look at the formula here. We have used different notation here in the second line of this equation. You can see now the notation has been changed to use a unique word in the vocabulary in the product instead of a particular position in the document. So from X sub j to W is a change of notation, and this change allows us to show the estimation formulas more easily, and you have seen this change also in the topic model presentation. But it's basically still just a product of the probabilities of all the words. Right? And so with the likelihood function, now we can talk about how to do parameter estimation. Here we can simply use the maximum likelihood estimator. Right? So that's just a standard way of doing things. So all should be familiar to you now. It's just a different model. So after we have estimated parameters, how can we then allocate clusters to the documents? Well, let's take a look at this situation more closely. So we just repeat the parameters here for this mixture model. Now, if you think about what we can get by estimating such a model, we can actually get more information than what we need for doing clustering, right? So theta I, for example, represents the content of cluster I. This is actually a byproduct. It can help us summarize what the cluster is about. If you look at the top terms, in this cluster or in this order distribution, and they will tell us what the cluster is about. And P of theta I can be interpreted as indicating the size of cluster, because it tells us how likely a cluster would be used to generate the document. The more likely a cluster is used to generate the document, we can assume the larger the cluster size is. Right. Note that unlike in PLSA, and this probability of theta I is not dependent on D. Now you may recall that the topic choice in each document actually depends on D. That means each document can have a potentially different choice of topics. But here we have a generic choice probability for all the documents. But of course, given a particular document, we still have to infer which topic is more likely to generate the document. So in that sense, we can still have a document-dependent probability of clusters. So now let's look at the key problem of assigning documents to clusters, or assigning clusters to documents, right? So that's to compute the C sub D here. And this will take one of the values in the range of 1 to k to indicate which cluster should be assigned to D. Now, first you might think about a way to use likelihood only, and that is to assign D to the cluster corresponding to the topic theta I that most likely has been used to generate D. Right, so that means we're going to choose one of those distributions that gives D the highest probability. In other words, we'll see which distribution has a content that matches our D the best. Intuitively, that makes sense. However, this approach does not consider the size of clusters, which is also available to us. And so a better way is to use the likelihood together with a prior. In this case, the prior is P of theta I. And together, that is, we're going to use the base formula to compute the posterior probability of theta given D. And if we choose theta based on this posterior probability, and we would have the following formula that you see here on the bottom of this slide. And in this case, we're going to choose the theta that has a large P of theta I, that means a large cluster, and also a high probability of generating D. So we're going to favor a cluster that's large and also consistent with the document. And that intuitively makes sense, because the chance of a document being in a large cluster is generally higher than in a small cluster. So this means once we can estimate the parameters of the model, then we can easily solve the problem of document clustering. So next, we'll have to discuss how to actually compute the estimate of the model.